2.4, number 148. We have a function f of x which is piecewise defined, and it is e to the kx to the left of 4, and it is x plus 3 to the right of 4. We're supposed to find the value of k that makes the function continuous. On this interval. On the given interval. Alright, so to be continuous means, by the definition, the limit of f of x as x approaches a must equal f of a for all values on this interval. Now, there's not really a question on any location except for 4 specifically, because we know that e to the anything x, right, the exponential function, is a continuous function, and we know that x plus 3, a polynomial, in this case linear function, is also continuous. The only problem making this possibly discontinuous is the fact that it stops being e to the kx right at 4, and then starts acting like this linear function right at 4. It picks up again on the right-hand side. So, because of that, we could have a discontinuity at 4. So the only question is on 4. So we really need to force, right? Need to force the limit of this function as x approaches 4 to be f of 4. Every other location from 0 to 8, we believe, is fine. So it's all about where this thing changes from one curve to another on these piecewise functions. So let's force this then, as we said. So we need, for this limit to exist and to be equal to the function value, okay, to exist, we need that the two one-sided limits should be the same. Right? We need this to equal this. Okay? We'll just force that to be the case. So let's see, the limit of f of x as x approaches 4 from the left will look like this. Limit of x approaching 4 from the left. What curve am I on? I must be on the e to the kx curve. So e to the kx. Okay. Now, e to the kx is continuous on its domain. So therefore, as long as we're to the left of 4, e to the kx is going to certainly approach e to the k times 4. Right? It's a simple substitution, because this part of the function here is continuous on the 0 to 4 interval. Okay? Now with the limit on the right, limit as x approaches 4 from the right, we're on the x plus 3 curve then if we're to the right of 4. So I'll put x plus 3 in here for the function. But again, this function is also continuous, right, on its domain. So beyond 4 to 8. So as long as we're slightly beyond 4, then this function is continuous and therefore should just evaluate within this limit to 4 plus 3. Right? A simple substitution again. Right? So if we want these two to be equal to each other, right, it must be that you would have e to the k4, I'll just write 4k because it looks better, e to the 4k will have to equal, I guess, 7. Okay? So for e to the 4k to equal 7, if we just solve that using a logarithm exchange for the exponential, we would then have 4k equals the natural log of 7, which means k will have to equal ln 7 divided by 4. So this will be the magic number, in a sense, back inside the exponential function, right? The first part of this piecewise function. ln 7 on 4 will be the magic number that makes sure that the limit that we were talking about exists. Right? It will force the two one-side limits to be the same. So the only thing we need to make sure now is that limit as x approaches 4 of our function, right, of f of x, now exists and will be apparently the number 7, right? It'll be 7. We just need to make sure that that will be the same as the function value itself. Will that be f of 4? If so, then this is continuous now at 4 because of our choice of k, and if not, not. So if we look back at our function, let's rewrite it very quickly here. F of x is now e to the ln 7 on 4, ln 7 on 4 times x. That's the coefficient on x now inside the exponential function, as long as we are between 0 and 4. And the bottom x plus 3 stays the same. And that was from 4 until 8, if I remember correctly. All right. So now, f of 4. What is f of 4? Well, when x is 4, I'm going to be plugging it into the second rule of this piecewise defined function. 4 plus 7 is, sorry, 4 plus 3 is 7. So therefore, we have exactly what we wanted. Yes, they are the same, right? The limit now forced to be 7 because of our choice of k is now the same as the function value at 4 being 7. So therefore, this has satisfied the definition of continuity at the location 4, since that was the only place we were concerned about, because again, that's where the function changed abruptly from one type of curve to another type of curve. And then we now know this function is continuous on its whole domain because the exponential function is continuous from 0 to 4 in and of itself, not inclusive, and x plus 3 is continuous from 4 to 8, not inclusive. So now that we've wrapped up the issue of the location 4, forcing it to be continuous, again, by basically forcing the two one-sided limits to be the same and solving for the k that makes it so, this function is now continuous everywhere.